right, people, in the future, this is part 2 after a break. So hope you enjoy. Let's see. So the bcrypt is installed. Hopefully, let me check the package JSON. Bcrypt. Okay, version 6. Let's use it. So we want to, when a request is coming, yeah, we want to, the endpoint that is responsible for registering our user in the database, before we register it into the database, we want to hash the password first. And we can do it straight ahead here, or you can do it as a middleware also. So you first hash the password and you say next, and then it comes here. But let's do it here, and then yeah, later when we, I don't know, refactor the code and so on, we put everything in its place. You know that this is the rec.body, the raw data that is coming in the request. I don't want to take it and save it to the database. I want to replace it with the hashed one. First thing first, let's import bcrypt that we installed here. All right. Import. It has automation of suggestions from Copilot. How can I turn it off? I need to check it later. I really don't know where is the setting. I have to find it. Because Copilot has a auto generation of just guessing what you want to do. It's not good for when we're learning stuff, okay? Anyway, let's import bcrypt. Bcrypt from bcrypt, and this bcrypt is gonna help us now to generate what we want, like the hashing a password. So where is the password is located? Is inside of the rec.body that is coming, correct? There is a request is coming, this is rec.body, and inside there is a password. In this case for Savin is rabbit. We're gonna take the rabbit and hash the password. So here we want to say const hashed password equals to. It's already showing it to you. I don't want you to see it. Bcrypt dot. If you put a dot, there is a bunch of information like hash sync, hash get rounds, get salt, compare, and so on. These methods coming from the bcrypt package. And we've seen there are different ways of using them in the documentation that we were checking in the website. We're going to use this one, .hash, for hashing. And this one is like returning a promise, I think, because the document was telling us. Hover on it. Come on. Yeah. Yeah, exactly. Oops. You can see it's returning a promise. And whenever we have a promise, you have two ways of handling promise, .then, and these things that you know it already, or a better, nicer way, async and await. So I can use await for that. Yeah. And this thing receives two things based on the documentation and based on what is written here. The first thing is the data or the password, the plain password that you want to create a hash from it. The second thing is salting. The salting is like rounds, how many rounds. Salt means, just let's take salting as how many rounds. Like you can give it provide a number like 10 times round, like hashing a password. We will talk about that. What does that mean? So the first thing, from where the password is coming from the rec.body.password. Are you agree with that? It's inside of the body of the password, the plain text. And I want to just say 10 times of, or 2 times of hashing, or whatever. Let's talk about 2 times and 10 times. What does that mean? As an example is like, oh, I hate it. It gives me all of these suggestions. Let me ask Copilot. I need to turn it off. Asking Copilot how to turn you off. Right. I don't want to use auto-generate code or suggestions from Copilot how to turn it off. Come on. So you're thinking too much. To this, use the GitHub Copilot enable setting to set it to false. Okay, let me find it. Where is this located actually? I think somewhere here. What happened? Come on. Enable, disable. I think this one. So it's enabled maybe. Oh, I think it's working. I don't know. Oh no. Okay, seems disabled. I really don't know. Let's see. So round, when you hash something, let's say you hash rabbit and the output, let's say, is look like this. That's the hash version of the rabbit. All right, and then you take this hashed one and you hash it again. So if you hash this one, it would look like, so let me show you. When you hash this one again, it will look like another hash. something like but to the same length. Yeah, you hash again this one, you take this and you hash this one more time, and then it gives you something like another hash. Yeah, so you can repeat this 1 time, 2 times. The more you hash, the rounds of hashing of a rabbit, the more you hash, the more secure it is, and the more you do, the more slower it will be. Okay, you have to find the balance between more secure and the speed, because if you hash it 30 times, 50 times, then I think it takes forever to hash it, a million years. I think we will test it, we will see. So you have to find a balance, how secure you want to be and how practical it is, how fast it is. Yeah, so for example 2 times, 3 times, I think is fast enough. Let me give it a try. Let's see. I just want to console log the hashed version. Actually, I think I don't have this snippet anymore. I have to type console log and this one. Okay. Hashed password. Let's give it a try. I want to make a request to register someone, and it's gonna come here, take the rect.body.password inside. I'm gonna hash it 2 times or whatever, and it gives us a hashed version of the password, and we just console log it. So let's see. I'm gonna do the same user, Savin. Definitely I get error, but doesn't matter the error because it's duplicating, yeah. But we wanna just see the console log, npm start. So let's see. Making the request, bang. The duplicating is here, doesn't matter. We want to see the console log hashing. It's here. Look at that, how it looks. So the rabbit is hashed 2 times, and we received something like that. We want to replace the raw password of rabbit with this one and save it to the database. We don't want to take the rabbit and put it there into the database. All right? So this is 2 times hashing. Let's test it more because it was fast, it was no problem. If I make it 10 times, so the more rounds you have, the more secure it is. Let's make the request again. Bang, and all right. 10 times of hashing still is fast and more secure. Fantastic. This is the hashed version of Rabbit. Let's make more rounds. Let's do it 30. Send the request. Bang. Now look what happened. Hashing 30 times, it takes forever, I think. It takes for million years. If you want to hash rabbit to 30 times, make it hash. That's why we're going to talk about, that's why you need to find the balance. How secure, yeah, this is going to, if it finishes a million years later, then it's very secure. It's not like crackable maybe. But it's not doable because it doesn't work. Your application always waits forever. So finding a balance is good, and most of the people come to this conclusion 10 times, 12 times of hashing is enough. Is enough secure and is enough like based on the speed and performance. Yeah, so 30 times really takes time, and we need to hash it only 10 times. That's enough. Security and the speed is enough, and so on. Oops, I've closed or user HTTP. Make the request again. Now it took 430 milliseconds to create a hash out of it, and that's it. All right, does that make sense so far? What are we doing? Great. So it's hashing a password. We are not still replacing it with the raw password, because still we're telling, hey, rec.body, whatever it is, because we just created that, we need to replace it. What we need to do, we can say rec.body.password, whatever it is, password. We want to replace it with the hashed password. Okay. So creating a hash one and replace it with a raw one, and then now let's save it to the database. Let's give it a try. I would like to create a new user, because this one won't be created. You can see we get duplicate. We have such a user. I'm gonna create this time Lotfi. Your name is difficult to write.
I know.
Lotfi, and
you can leave the J out of it, so only Lutfi.
yeah, that would be correct. That J is a bit difficult. Why it's there? Is it written like that?
Yeah, the J is actually international because not everyone can read it. That's why it is.
Ah, okay.
But it's not with J.
Nice. But I've written that anyway. So Lotfi, the password is, let's say, fuck it. That's the password. Yeah. And sorry. Lotfi@gmail.com. That's the username, and let's. Lotfi is trying to register to our website, sending the request. Fantastic. And look at that now. It's saved successfully. We received the response. The new user is this object, and you can see the password now is replaced with the hashed one. Now imagine if someone gets access to our database, it can see bad data of Shinedu, which was not hashed. This is the password, the raw password of Shinedu. This is the raw password of Rabbit. They can really easily access to your data, login to your data, maybe Gmail or whatever. But Lotfi is secure. Lotfi has a hashed password. Even this data leaks out. It's not usable. They have to now start and sit to crack this. What was the password behind the scene? So this is referring to fuck it, so to say. Does that make sense so far? Great. The question is, now when they log in, how do you do this? Because when they log in, they don't put this one into their login. When they log in, they again try to log in with the raw password. Yeah, the Lotfi comes and now want to log in. They put their username and password to log in. How do you do this then in the backend? Because what you saved in the database is this one. You cannot compare fuck it with this one. You cannot find it. Let's see how it works then. This is the part of now registration. Now let's see how the authentication, so to say, or login works. We need another endpoint responsible for login. Yeah, we don't have that. Let's create that. So let's create it somewhere here. Which method is it? Is it a get? Is it a put? Is it which method for login you would have? Why get? So let's say if you use get, a request, let's say coming here, how do you handle who is this person is coming, find it in database. If the password is correct, if the username is correct, then you say, okay, let them in, let them log in. Because when you say get, you want to get some information. But how the password and username coming in the request? Because there is a password and username is coming from a specific user. They say, hey, this is my password, this is my username, I want to log in. So you need to receive this data. And with get method, we don't receive that. Why? Oops. Is it clear what I'm asking actually, or it's not clear what I'm asking?
Not clear.
Not clear. When you, how do you choose here to be post and here to be get? Why? What is the difference? Why you don't choose here to be get method?
Maybe because we need to do some validation before we post it, or these kind of things. We cannot post it directly in here, or no?
No. Yeah, Shinedu, wanted to say something. I don't hear you.
I'm a bit confused. I'm just thinking of something. Maybe to find the user by ID or something. I'm just thinking of...
Yeah, you don't know the user that is not logged in, because if they don't know, they're not logged in, you don't know their ID. They now they want to try to log in, so you don't know them still. The only way that they want to log in, they put their credentials there, yeah? And then you find, oh, this is Shinedu, and then this is the ID of that. So it has nothing to do with the ID now. The question is, which method to use? Post, get, put, patch, and why?
I think post.
Post, exactly. Why? Also, Izam says
Because
post.
we're sending sensitive data.
Exactly, we send data. We expect to receive data. So here we expect to receive a data from the rec.body. It's some data, we want to take it and register it in our database. Rec.body, save it to our database. It's a new user actually. Also, when they log in, we expect some data coming from the rec.body. Their credential, username, password, or email, or whatever. This means the get method has no body. It's a post method. We can access to the rec.body. Fantastic. The post method, which means we expect some data coming. And I want to give it as a /login. Yeah. So when a request is coming to this thing, let's say, local assessment /API /users /login, then it comes here. We want to handle that, so we can say async rec res next. Let's try and catch. All right. When the request is coming, we have the body of the request. Let's start with console login. Log rec dot body, which is the data is coming. For now, let's keep it like that. We don't send any response. We don't send anything. Just let's test the endpoint. I'm gonna make the request to. I'm gonna copy this to be a bit time saving. So the request this time goes to /API /users /login. This is the endpoints that we want to send the request. Content type application JSON. The method is post. So the credentials, it depends on how you want to build your login, because some login systems, they use email with password. Some systems use username and password. Some of them, both of them, email and password. It's just, you decide how to do it. Let's use username and password, for example. So we can get rid of this for logging in. This means you expect from the user to provide you to this endpoint a username and password. Let's test it. This is going and we have access to that. The request is coming to /API/users. We have the console log working, the endpoint working perfectly. It's waiting forever. You know why? Because we don't send any response. It's just a console. Fantastic. When we see the endpoint is working, we have access to our console log of rec.body. Now, we want to find the user. If this user, the first step is like that. When you log in, when there is a login information coming, first you need to know if you have this user in your database. First you want to find it. How do you find it? Based on the username that is coming. You go to your database, you say, okay, let's find by username. If you find someone, good. If you don't find it, you say, hey, I don't have such a user, or the username or password is wrong, something like that. If you find it, the next step is to check if the password is correct. Yeah, there are different steps. First thing first, let's find if we have such a user in our database. Let's find it. Const find user equals to await. Let's we need our user model dot find. So we can find now by username. You can find it by email. It depends on, as I said, which data you're expecting to come. We expect a username and password, so I'm going to find it with username. So I put an option here. I want to find a user with the username which is coming from rec.body.username. Yeah. Or the best thing, if you want to make it shorter, because always you say rec.body.username, it's better to destructure it. It's more nicer. So we can destructure username and password from the request.body. Rec.body. This is nicer. Now you don't have to just type rec.body, 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 and then we can get rid of all of this. Very more short. I'm gonna find a user, and then you provide some options. Which user? It should be an object, and the username that has this username coming from the request. And because the value, the key and value are the same, username. In JavaScript, we can just get rid of it because they have the same naming like that. Great. Let's see if we can find such a user in our database. I'm gonna console log the find user. Let's test it now. ID structure, whatever I need from the body of the request. I find the user by the username. If I find it, I console log it. If I don't find it, I console log it. Let's see. So the username is Lotfi2. I want to give it a try. I know that I don't have such a user, Lotfi2. Let's see what we get as a console log. We get empty array. Oh, find it gives us an array. what if I want only one object to find? Is there any other method? Find by, what do we have? Find by ID. We don't want ID because we don't have ID of the user still. We have to find it in this way anyway. So because I don't have the user, it gives me an empty array. Yeah, let's see, but I have Lotfi anyway in my database. If I send a request, you can see I receive Lotfi inside of an array. I don't like it that I have it in an array. You know, there should be a method, because find by ID, it gives us exactly an object, but find, it gives us an array. Yeah, but it's okay, it's fine. So when we find it, the array shouldn't be empty, so it means we have access to that. We can say this one. Does that make sense, what I'm doing? It's JavaScript? Find one, thank you. I was looking for that, find one. But this is JavaScript. It's an array. If I receive an array, I say, give me the index 1. Yeah, so the index 0, like the first item. The find one. How I'm so stupid. How I cannot find it. The find one doesn't give us an array. It gives us exactly the object. Yeah, that is better. Why did I forget this? Now let's give it a try. We get not an array, we get just exactly the object of the person. Let's see. Let's find the Lotfi in our database. Fantastic. We have it in our database. What if we don't have it in our database? I think it returns null or undefined. Null. Alright? Based on if you receive it or not, you can prepare your error handling. We can say, okay, if I don't find the user, yeah, if I don't find the user, I'm gonna prepare a nice error with my beautiful next and sending it to the global error handler with one status inside. This is 401, not authorized, I think, because we don't allow them to log in. It's bad data or wrong username. And here we prepare a nice message. We don't want to say your username doesn't exist. We want to say, because if you say the username doesn't exist, it's leaking data, because they know, okay, I know it's not the password wrong, it's the username is wrong, let me try to another username. You shouldn't tell exactly which one was wrong about the login system. You have to tell the username or password is wrong. Okay? Something like that, that you don't give it a clue that if this username is wrong or the password is wrong. Yeah, that's the point. All right, and then you want to return here because you don't want to continue the code after that. Let me get rid of this mini map here. Yeah. Where was we? Where we were? Here. And then after that return, this means stop the process here, don't continue the code. So if you don't find it, we send a nice error. Let's test it one by one. Bang, Lotfi 2, I don't have you. What? Invalid status code. Ah, in a strange way I use it as a string. Yeah, exactly. The status codes are numbers, not strings. All right, let's give it a try. Thank you, Jacob. Bang. Fantastic. 401 unauthorized error. The username or password is wrong. Yeah. The front end doesn't know if the username was wrong. Yeah. But we tell it both of it. One of them is wrong. This is the first step. So what if we really have the Lotfi? We find it in our database. Now what? Because now it's waiting for the next step. It's not an error to send us an error. So then it never goes to this block of the code to send the response of the error. It comes here. If we find it, we need now to compare the password. Because if we find it, we have it in our hands now. So we want to compare this hash one and with the password that is coming from the request, which is, let's also console log the raw password, the plain password. Console.log plain password coming from the request. Yeah. The password VD is structured from the rec.body. Let's test again. Bang. What? Where did I put the console log? It's exactly here. Yeah. Thank you. Typo. Console log. Thank you, Jacob. Sending a request. Yes, you can see that the plain password coming in the request is fuck it. And also I was able to find Lotfi in my database. The password is this hashed one. I need to figure it out to compare it, this one with this one. If the hashed version of this is this one, then it means they should be logged in. Exactly. Jacob says we need to compare the password. So there is a method inside of the bcrypt that we already used it as a one method we used here to hash the password. There is another method to compare the passwords. So after we find the user, we pass this part, we find the user in our database, we can compare the password. Let's say const compare passwords or something, because compare password returning boolean like false and true. It's better to write it something like that. Or is or does pass or no, do pass or no, is pass. It's wrong as a grammatic, but it's better. Password matched equal to. So because when you're creating variable and you expect a boolean as a result, it's good to save it something like, have a naming like that, because when someone reads that, it knows, oh, it could be boolean, false and true. Is it matched or not, true or false? That's a good way of naming if something returning boolean. Yeah. So bcrypt, we needed dot. There is a compare method inside. Okay, you can see the compare method returning promise and boolean, which means true or false. If they match, it returns true. If they don't match, it returns false. All right, so here we can compare the passwords. What it receives the data, the raw password that's coming in the request, the raw password, so to say. And the second one is the encrypted one, which is the one we save to the database. Yeah, so let's provide that. The first one is the raw password, which is we destructured it from the rect.body. The next one is the hashed one, which is inside of find user. We found it already. Find user variable dot password. This one. So behind the scene, it's going to compare this both. If they match, it's going to return true. If they don't match, doesn't return true. Behind the scene, how it works, it takes this raw password and creates the same way that it was created, this one, when they were registered. It creates the hashed password. And if the hash password that is created again is matching with the one that we saved it to the database, then it means, yeah, it's the correct password. It's not reverse that to see if it's really the password. Fuck it. It's not reversible. What it does behind the scene, it creates again from the raw password 10 times of salting the way that it was created before, creates the hash. If the hash that is created is exactly like that, if they match, true. Yeah, let's test it. I'm gonna console log now is password match. Either it's true or false. Okay, let's send the request now. Lotfi is fuck it the password. We know it. So if I send the request, you will see, oh, it's not handled, the promise. When you receive something like this, pending and promise, what does that mean? Yeah, we need to wait for that. Making the request, bang. You can see the plain password was fuck it, and it compared it to the one that was saved to the database, and it says true. Fantastic. This is true password. Let them in. Let them log in. What if it's wrong? Fuck it too. We know this is not the password. Let's test it. We should receive false. False. They don't match. Based on true and false, you can let the user in or not. So we can say if the password is password not match. So if it's false, then we're gonna send a nice error, again the same error, because we don't want to say your password is wrong only. You don't want to leak any information. You just want to say the username or password is wrong. Yeah, if they don't match. Let's test it. So the username is correct, the password is wrong. We send, bang, a good response is coming now. What if now the password is correct? We want to send a response for that. So we're going to say, let's return here because we don't want to continue that. So everywhere you have a next, you're going to stop the process right there. Okay? If they don't, the password don't match, it comes here. What if they match? Then it comes to the final section. You want to say, all right, press dot status 200 dot send. You're going to send a message. Successfully logged in, and also you want to send the information data of the user that was logged in, the entire object, which is the user is find user variable that we found it in our database. All right, let's test it. So there is a bunch of things happening here. The request is comes with the structure, username and password out of it. First we try to find if we have really such a user in our database based on the username, maybe based on the email if you want to receive an email. If you don't find it in your database, you prepare a nice message, say, I don't have you. But if you find it, it goes to the next step. We want to check if the password is correct. We compare the password with the raw password that is coming from the request with the one that is saved to our database. If they match, if they don't match, it returns false. Then we say it's wrong. But if they match, it returns true. It jumps straight ahead here, then successfully log in. And that's the user actually. Let's test it. Bang. Try again. Bang. Oh, Lotfi2 is wrong. Fuck it 2, the password is wrong. That's why we get the username or password is wrong. Let me give it a try of Lotfi and fuck it. And bang. Now successfully Lotfi is in. Successfully logged in, and also the information of the Lotfi that which will be sent to the front end. This is basically a realistic authentication login. 90% of it is correct. The last 10% will be later, tomorrow or the day after tomorrow. But that's actually the logic behind the scene. Does that make sense? What we did so far is everything clear. So if you test with wrong username, it doesn't work. Error, the username and password is wrong. So it should be exactly the username correct and the password correct. This is how the things works behind the scene. Question: do you have error, or will you be able to solve it, or do you have any question about these things? You can later, because you can have all of this stuff checking as a middleware. Yeah, you can save it as a middleware and use it as a middleware here. Okay, there is a bunch of ways to do it, or you can straight ahead here that I did it, you can do it here, or just hide them into a middleware that you can have a more cleaner code here. There are different ways to do it. Like to structure your code. That's it. So the main thing is, let's get back to our notes. Do not encrypt passwords. Do hash passwords and save into database. Do not save raw passwords in database, and That's it. That's the wrap up. We are finished. We have still 15 minutes and it's your time that you can ask questions if you want. Yeah. Isam.
I have a question about, for example, it was encrypted like 10 times, but it was decrypted like by just one try. Like, does that make no difference, like the amount of encryption?
Can you ask your question again? Because I didn't understand that.
Because on registration, we encrypted it 10 times,
Yes.
but then we decrypted it in one try.
Ah, okay. The question is, that's a good question actually. Isam asked that we hashed it, not encryption. Encryption is wrong. We don't encrypt it because encryption is reversible. We can see what was the plain text. We are hashing that. And we hash it 10 times. Yeah. The way that it was hashed is done exactly when we compare it. Behind the scene, the bcrypt has some automatic system that knows that this hash that we have it in the database, somehow there is a signature inside, could be, that knows it how many times it was hashed. Yeah, and then they use it to just create it again and compare it, and then gives us if it's matching or not. So they do it behind the scene. I don't know how they do it, but they know that it was kind of 10 times hashed. All right? And it couldn't be more than 10 times because they already told us that if you try more than 10, like 15 or 20, you can never hash it because you saw that it takes forever to hash something more than 10 times or 15 times. It takes for a million times. So they know that it could be around 1 time to 10 times of hashing. So they could be trying everything behind the scene. Trying 1 time hash comparing, 2 time hash comparing, 3 time hash comparing. Or they know exactly how many times it was hashed. All right. That's all, and I have 3 exercises for you today. Let me see. This is the first exercise. Encrypt decrypt API is kind of working with the API Rode 13 that we've seen, and like some encryption and decryption practices. Not hashing, it's encryption and decryption. And there is another exercise for very interesting one actually. The next one. It's a simple password cracker. You're gonna have a cracker actually, and there are some already main code there that you don't need to do anything with them, just use them. Yeah, there's a structure there that you can crack passwords with this simple thing. And another one, which is the real exercise about bcrypt, which you're gonna use the bcrypt package, and then you're gonna create a registration and try to register and so on. This is the about bcrypt package that we've did today. 3 exercises, so you will be happy with them, hopefully. We have still 15 minutes, but we can finish that. You know what? Before we finish it, maybe I'm gonna talk about something that I think I didn't talk about. Did I talk about DDoS attack to you? Mickey says, no. Okay, maybe I forgot. It's just general information and it's good to know it. How can I bring this div to the middle? Justify content center. Is it possible? Which one is it? I want to inspect this one. It's the entire one. No, it's not the middle one. Okay, anyway, it doesn't matter. Oh, come on. Give me something new. Oh, good. So the DDoS attack is a very common attack that can happen to your server. Okay. Let's say, let me draw it in another way. Let's say this is your laptop. I think it looks like a laptop. This could be a server somewhere in the internet, because servers are just computers somewhere in the world, yeah? Or it could be a server, some bunch of information there, and there are requests coming to this server everywhere, and then it's handling that. One request is to log in and response back, another one give me products, response back, another one give me bicycles of red type. So it could be at the same time a lot of requests coming from your website. Let's say if you go to Amazon.com, it's not only you that at the same time you are browsing Amazon.com. There are a lot of people browsing Amazon.com. Yeah. So someone is searching for shoes, someone is searching for, at the same time the server is handling all of these requests and response back to all the individual persons that they're searching into the website. Okay. Servers, based on the good or bad or how many requests that they can handle, you can define them if they are a good service or not. Yeah, because some servers can handle, let's say, 200 requests at the same time, exact time that is coming. If it's become 210, then it could be slow. The server can be slow, doesn't work, and so on. Okay. The attackers, they use this as a flaw, actually. So DDoS attack is not like stealing something, it's just ruining something. It's just like you turn off the system, the server, you just explode the server. Behind the scenes, like that happened with a couple of days ago with Israel. So we did it to them. If you want to attack some server just to shut it down, So imagine this was inside of this country, because we are recording, I don't want to say these names. The server is located in that place, and it could be anything related to any bank or something. And if you want to shut this down, you don't want to steal anything, because if you want to steal anything, you have to crack and hack inside of it to access the database and so on. You just want to just hurt it, you know, that it doesn't work. The system is down, so to say. What you would do is, like, you're gonna have to so there are a bunch of ways you can hack to different systems in the world. Let's say with one email, just a little email, you can send a random email to anybody. That email, when it's inside of the inbox, they can just run some function. Yeah, that function is just waiting for an order from someone is sitting. Let's say this is the attacker, can hack a lot of systems in the world just with sending some email to them. Somehow in a way that can have access to these computers in everywhere in the like the world. My computer, your computer, doesn't do anything to that. It's just telling to this system, hey, whenever I say this system, let's say sitting in Africa, this system sitting in US, this system sitting in Germany, lots of them, millions of computers or millions of the systems that they can make a request. Yeah. What it does, this attacker, what it does is just telling them, I want you, all of you, at the same time, at the exact amount of second, like exactly at 2 o'clock, let's say, make a request to this bank system. Just go to this website. Yeah? At the same time, all of them, let's say these are millions of systems at the same time listening to this person, it's just write a function. Make the request to israelbank.com, let's say. Because the server, as I said, can handle requests at the same time. Let's say there are good servers, they can handle millions of requests at the same time and answer and make a response, and they are really fast, nothing happens to them. Let's say if it's not a good server, you can send million or billions of same requests with all of them at the same time to bank.com, and what happens to the server of bank.com says, oh, 2 million, 10 millions of requests at just in a moment. Server cannot handle all the requests to respond back. What happens? The server says, okay, I cannot do that, I'm gonna shut down. And what happens is gonna shut down and doesn't work. And then when you go back to the website, it's down. It says doesn't work. This is the DDoS attack, so to say. And it happened easily before, but now if you don't have you have to have access to a lot of systems in the world. Or there are, maybe if this attacker is so rich, it can have, I don't know, an inventory of systems, like million systems in one place, and it can do that also. But it's not possible like this. Maybe they don't have it. They have to first hack into other systems in the world, and what they do, they send a request to say, hey, make the request to this bank. The server is down, cannot handle all the requests at the time. This happened to so Iran did this to most of the systems of the Israel. They were shut down for days, and they could be back again, and they are shut down. These things, the cyber attacks can happen. So this is the DDoS attack, so to say. Does that make sense, what I'm telling? All right, fantastic. That's it all, guys, for today, and let me stop recording.